Solving quadratic equations by graphing, Part 1. In this lesson, our friend Joe Quadratic will be solving quadratic equations by graphing. With this method, he will be able to solve quadratic equations such as this one, n squared minus 2n minus 3 equals 0. In order to graph this equation, something will need to be different. With only one unknown, there is no way for him to graph on a coordinate plane. To explain the concept of solving by graphing, the technique is to change the quadratic equation into a quadratic function, and wherever the function crosses the x-axis, will be the solutions to the quadratic equation. It's as simple as reading the solution as points on a number line. For example, this graphed quadratic function would be from a quadratic equation with solutions at x equals -7 and at x equals 3. It will be like reading solutions off a number line. Now back to our problem. In order to graph on a coordinate plane, Joe will need to change this quadratic equation into a quadratic function. The first thing he does is change the 0 on the right side to a y. The next step is to convert the n's to x's so it's graphable on an xy coordinate plane. Joe has now created a quadratic function from a quadratic equation that he can graph on a coordinate plane. For cosmetic purposes, Joe switches the function to have the dependent variable y on the left side where he is more accustomed to working. Joe now creates a table where he will obtain points to be graphed. But his question is, where should he start to plot points? Fortunately, there is something called the quadratic formula shown here, and it's this part of the quadratic formula, y equals -b over 2a, that is the key of where to start. This portion of the quadratic formula, x equals -b over 2a, the front portion, is the formula to find the equation of the axis of symmetry of the parabola or quadratic function. But to use this formula, we need to identify the a and b in the function. In the function, a is 1 since we have 1a squared, and b is -2 since we have -2x, and c is -3, and that's our y-intercept of -3. Now Joe rewrites the axis of symmetry formula with the parentheses into which the constants a and b can be inserted. The b goes into the numerator and the a into the denominator where the parentheses are, and here the -2 is inserted into the numerator and 1 is inserted into the denominator. And all simplified, that equals 1. So this 1, or x equals 1, is the axis of symmetry and goes right in the middle of the table as our first input value. And from here, since he has the value of x, Joe takes the 1 as input to determine the other, or y coordinate, to be able to plot the vertex or minimum of this quadratic function. So that ends up being f of 1 equals 1 squared minus 2 times 1 minus 3. And that simplifies to f of 1 equals -4. And Joe places the output value of -4 in the table as output right next to the 1. And with that center value in the table, he can fill in the other table inputs, 3 inputs on either side of the vertex of 1. And for the input value of 0, the y-intercept is -3, so he places -3 for the input value of 0. And because x equals 1 is the axis of symmetry, he knows that an input of 2 will also have an output value of -3. Next, he can try an input of 3, and that will be 9 minus 9 equals 0. So 0 goes next to the 3 in the table. And because of symmetry, the 0 shows up reflected on the other side as well. And finally, he inputs 4 to get the table filled in. And that will be f of 4 equals 16 minus 8 minus 3 equals 5. So he places it into the table. And because of symmetry, the 5 goes on the top of the table as well, opposite the -2. He now sets up his graph paper to plot his points. Here's the vertex at 1, -4, and the axis of symmetry of x equals 1 plotted. And here are all the other points plotted. And here's the parabola drawn through the points. After graphing, he can pinpoint the solutions where the function crosses the x-axis at x equals -1 and at x equals 3. These solutions are also called roots, x-intercepts, and zeros. Going back to the original unknown, n, he says that the solutions for his original equation are -1 and 3. Here's the next equation we'll look at. -x squared plus 3x equals -4. Stop the video. See if you can solve this one by yourself. Hint: You will need to set the right side of the equation equal to 0, then replace the 0 on the right side with the dependent variable y. Also, to find a starting input value for a vertex, you can use the formula x equals negative b over 2a, then work from there. Restart the video after you've graphed it and solved it. Okay, now we go. Joe gets the right side to 0 by moving the negative 4 across the equal sign. That becomes negative x squared plus 3x plus 4 equals 0. Next, he changes it into a function by changing a 0 to a y and swapping sides, so the y is on the left side of the equal sign. Joe then uses the function to create a table. Joe plots the points. Now he draws the curve through the points. He sees the 2 points where the function crosses the x-axis at x equals negative 1 and at x equals 4, and writes the solutions here. He writes his answers in brackets, which is set notation. In set notation within brackets, each number separated by a comma will be an answer. If the numbers are in parentheses, that would be the notation for a coordinate pair or an x and y value. But negative 1 and 4 are not a coordinate pair, but distinct and separate answers. Joe observes that if he looks at the table he used to draw the graph, he finds the solutions here at negative 1, 0 and at 4, 0. This means that if Joe gets pretty good at reading tables and finds where y equals 0, he may not have to draw the graph to find the solutions, but just use the table if one is available. You might remember from the video where Joe Quadratic was introduced to the quadratic equation he tried to solve but could not. He tried to combine 3n squared and 5n but could not do it because they are unlike terms. Now Joe will try to solve this quadratic equation by graphing. Joe changes the 0 to y and the n to x to convert it to a function he can graph on a coordinate plane. Then he switches it around to get the dependent variable on the left side. He locates the axis symmetry using the formula x equals negative b over 2a, and with an a of 3 and b of 5, this is what he gets, an axis symmetry of x equals negative 5/6. Here's a table with the vertex and all the other adjacent values filled in. Here's the axis symmetry of x equals negative 5/6 with the vertex of negative 5/6, comma, negative 4 and 1/12. And here are all the other points from the table plotted on the coordinate grid. Here's the curve drawn through the points. And he sees one x-intercept at negative 2. And it makes sense since he sees the coordinate negative 2, 0 in the table. But what about the other solution? We see that it's here between x equals 0 and x equals 1, but where exactly? We'll just leave a question mark here until we find it. In the table we don't see that second 0 for y, but notice that y is negative 2 at x equals 0 and 6 at x equals 1. So that confirms from the table what we see in the graph, that the other solution will be somewhere between 0 and 1. One thing Joe can do is try different numbers for x until he finds the second solution. Here he tries 1/2 or 0.5. It simplifies to y equals 1.25, pretty close to y equals 0, but still not a 0 and not a solution. Next he tries 0.25. He gets negative 0.5625, closer to 0 but still not 0, so 1/4 or 0.25 is not a solution either. Next he's going to try 0.35 for x, and that is between 0.25 and 0.5. He gets y equals 0.1175, even closer but still not 0. Joe realizes that to get that second answer it might be possible by continuing his search, but Joe has some important things to do. This is starting to take away from his basketball playing time. He remembers that his teacher was going to show him how to solve quadratic equations using the graphing calculator, and for that method to solve this problem, at least for that one solution, Joe will return in Solving Quadratic Equations by Graphing Part 3. This has been Solving Quadratic Equations by Graphing Part 1. Thanks for viewing.